Thanks very much for that. Yeah, we're going to step back from the detail of building design and architecture and show you how two markets have developed, and in some ways they're quite counterintuitive the way they've developed, but you'll see there's some obvious reasons for that later on. I'm an engineer, but I've spent most of my career doing technology transfer in the wood industry. We're very excited now. We've been working with architects and engineers for the last 2 years, and we run a conference called Changing Perceptions. And if you go back to that session that we were just in, it's not about facts, it's about emotion. And we've learned that architects need a lot of emotion to see the way, but really with the sustainability push and pull, it is actually happening. And you'll see some of the challenges in engineering in two different markets. We're also, at the end of this, you might put two and two together and say, well, we don't have a WoodWorks program in New Zealand. I'm working on starting that now in concert with the government. Our government didn't like wood for a long time, but it's recently changed, and that's a positive environment. Whereas Australia's had a WoodWorks type service for several years, and they've learned from both Canada and the US on that. So some of the things that are counterintuitive about the market developed in New Zealand and Australia is that New Zealand, if you travel New Zealand, you'll see there's forests everywhere. We took a tree from Monterey, California, and it is 90% of our plantation forests. In New Zealand, we also actually made an accord with the native forest owners and the conservation estate that we stopped cutting native timber over 25 years ago, and that's a national accord with Greenpeace, Forest and Bird. And yet in Australia, there's still that tension. There's a tension. When they cut wood in Australia, it doesn't matter if it's a eucalyptus that was planted or it's a native eucalyptus. There's a public pressure around that wood, and yet their markets developed quicker. If you look at that wood, the wood supply in Australia, they're a net importer of wood. In New Zealand, 50% of the wood that's cut goes to Asia as logs. We have a free market, but despite that wood excess, there isn't a huge impetus to build CLT plants up until now, despite that wood surplus. So that's a bit counterintuitive. Also, the engineering fraternity and the architect fraternity, you'll see through my talk how the challenges are different and how they've been solved in both countries. So what's up down under? Australia's developed strongly in that market. They're a net importer. They don't worry about importing wood. And the KLH and Binderholz have been the major suppliers there. And they've developed a system now, you'll see, with the two major users of wood, where they bring in standard billets of CLT panels from Europe, and then they have their own plants operating now. And that's been largely developed by two companies. It's backed up by local expertise, and because of the huge amount of effort that the Australians had to go through to get that supply, they developed their own in-house architecture and engineering, and that's where they leapt ahead. We all know, I think in the wood fraternity, the Forte building was one of those early ones that everyone heard about in this funny old race to get tall. Is it tall, and now is it pure timber? So the Forte building in downtown Melbourne, yeah, it was a great showcase. They now have local supply in Australia. I'll talk about that a bit later. But yeah, they do have that WoodWorks program that's more strongly developed. In contrast, in New Zealand, we don't have large engineering firms, and our architects are all small. By definition, we're spread out like Canada, lots of small communities dotting through the country. And so if you're an engineering firm and you want to do wood design, it's a major step to take maybe 20% of your guys and set them on this path of learning about wood. So that's really held us back. The other thing about, if you talk to an architect in New Zealand, they love wood, but they love Italian wood on a decorative entrance into the building, or a very expensive government building where the ministers want to show off wood. When you talk about the wood that we grow there, the architects don't want to know about it. So there's a challenge for CLT to be accepted as a decorative piece in the building. But I think sustainability will drive that. So here are the two major players. You've heard the name Lend-Lease many times because they're international. And there's the Forte building. The second building I did wasn't necessarily tall, but it was the Docklands Library in a Docklands redevelopment in Melbourne. And of course, in downtown Sydney, C2 Barangaroo is an office development that has been very well accepted by the office market in Sydney. And Strongbuild are doing a lot of multi-residential. They're a small family company that has just embraced wood and particularly CLT. So Australia's got a number of advantages. This isn't counterintuitive, this logic. It's dry, it's very dry. A lot of the places in the East Coast where the big major cities are, that dryness isn't as exaggerated as it is in the middle of the country. They don't really have an earthquake risk, and their building codes, they were able, with their Wood Solutions program, they've developed solutions that are deemed to satisfy the code, and they actually did that fairly quickly to get mass timber into the acceptable market. In contrast, it's counterintuitive. In New Zealand, we have a performance-based building code. Everyone has to prove that they meet the seismic code, so there was really no barrier, but it didn't develop so quickly. The real advantages they have is with the multi-story buildings, their city sizes and populations, their urban living, and their pure scale, that some of the cities in Australia are as big as half of New Zealand. So here's, in contrast, the New Zealand market development, and our latest one is student housing, Otago Polytech. That was a very successful CLT project that was recently completed and supplied by XLAM. And that one's actually been made open source so that there is the ability for other architects and engineers to learn from that building. The one closest here is an Indigenous peoples meeting center. It's in a rurally depressed area. It also had a challenge. It was on an old riverbed, so timber was the obvious solution. And when we moved to Christchurch, a lot of the solutions, that's a backpackers, and that was all done in full CLT, but it was also in one of the areas in Christchurch that had suffered heavily from liquefaction, and they simply couldn't get concrete or steel to work on the site. And now we've got a development which is done, it's emergency housing for people who are needing to be put into a home before they get a permanent home by our government housing corporation. And they're using CLT even though it's only 2 stories, but it's a fast solution. So some of the solutions are developing for reasons other than what you might think. And this building over here was one of the first ones that was built after the Christchurch earthquake, but it wasn't built in Christchurch, but it was actually something that we were ready with the solution. So you've heard of the rocking wall, shear wall solution with the energy dissipators. It was developed at the University of Canterbury before the Christchurch earthquake, and those of us in the wood industry, when the earthquake struck, the second earthquake struck in Christchurch in 2011, we thought, well, the wood industry has a solution. But as that whole city was devastated, the developers and the insurers just wanted to get what they had before back where they had it, and they weren't interested in wood, even though we had this complete energy solution that PTL Consulting has, they're doing it at PV Hall at OSU. So some real contrasts, but where there is corporate interest, so Trimble's a global corporation, and straight away they built a timber building in Christchurch. So where there's strong corporate interest, it does happen. But of course the risks in New Zealand, there's the devastating earthquake, and if you're not aware of that, it wasn't the magnitude of the earthquake on the Richter scale, it was the huge side forces and down forces that came during that earthquake that really devastated the whole building infrastructure that was there. But we have a lot more rain. We're very much like Portland, like Oregon. It looks the same, it feels the same, and the only reason it's green is because it rains. And if I was running a conference 15 years ago, and I've been doing it for 25 years, you wouldn't typically do, this is the emergency exits, this is, if in the case of this, that. When you do a health and safety thing at the start of a conference in New Zealand, everyone just stops and listens because it keeps on happening, and so they're very aware of it. And our building codes, they're constantly being updated, but the biggest problem we have in New Zealand is there's a lot of the old concrete buildings that really aren't, they're 40% of code, 50% of code. So there's a huge infrastructure of buildings that don't even meet the code. They haven't experienced an earthquake. And now there's quite a dilemma there on what to do with them. There's some historic buildings in Dunedin, which was the original financial centre of New Zealand, where the buildings are not even viable. If they told you, so the government was going to push the code through to say you have to be 70% of code in the next 10 years, but they're encountering a lot of resistance from building owners. So in New Zealand, we actually need a solution to prop up those insufficient buildings, but we haven't got there yet. And very much in New Zealand, the reason our market hasn't developed is we have a suburban living mindset. And when you talk about multi-residential buildings, people just think of the buildings in England that are just ghettos with too many people in too small a space. And so we have some real myths around residential, multi-residential. And one of the most famous books in New Zealand ever written was this half-gallon quarter acre paradise. In other words, you can't live unless you have a quarter acre to put your house on. But we're getting through that. So case studies in Australia, this is the latest building that Lend-Lease is built and sold, and it will be occupied by Oricon consultants, Oricon engineers. It's 5,000 cubic meters of CLT and 1,500 cubic meters of glulam beams and posts. And it's one of the developments. Lend-Lease talk about how easy is it to do these things and how they're doing a lot of exposed CLT with good treatments on the walls, and they're very much selling the biophilic experience for the employees, and the corporates really just can't wait to get in there. And yet, despite all that, Lend-Leases, that's probably 1% of the builds that they do is in wood. So it's a contrast. They seem to be able to do these things and sell them right off the plans quickly. And maybe Lend-Lease will ramp up, but they don't do very many for how successful they've been. In contrast, Strongbuild is a family company that was building houses until they discovered binder holes. And they're actually coming at it from a different angle. They've done a lot of affordable housing, retirement homes, and MacArthur Gardens is probably the most toured set of buildings, 2017. The managing director, I asked him about what were the challenges on the project, and he said, I was doing tours all the time. I had to get someone else to manage the project. But 3 towers, 6, 7, and 8, and it's on a concrete base, 2,600 cubic meters of CLT. To do the conversion, multiply by 35 to get cubic feet. But it's also, this one is quite an interesting one. It's got a retirement home in part of it, and then affordable rent. The focus was on affordable rentals for local workers. It's in the suburbs in Sydney. Sydney's just like New York. It's massive, and it's hard to get to work if you live a long way away. So yeah, quite a social platform behind that one. And this is the latest one that Strongbuild are doing. It's Avio Norwest. That's another one in the suburbs, and it's got shops in the bottom, and then once again, I think there's 2 or 3 towers of living. There's a shot of it under construction, and that's going to be completed shortly. But the other thing that's probably really developing nicely in Australia is they're not purist about it. The hybrid, there's very much the engineers and architects have accepted that the hybrid model is the best one. So as we've heard in other sessions today, it's about trying to get the right product in the right place. And I think it's been quite instructive coming here today to say, get in early. We haven't had BIM on these projects typically, like Brock Commons, where everything was done in the virtual design and build. But I think the hybrid model's about using concrete in the lower levels and then going up. But there's certainly some lessons to learn from those of us from Australia and New Zealand who've been here, looking at getting that suiting the CLT manufacturer, or talking to them early to make sure that the spans you're designing with your engineers and your architects fit exactly from the original supply. Moving back over to New Zealand, this is Otago Polytech, and it's a great study, and I think that one, it's in a quite a conservative area, and it will actually help develop the market because it's open source, and because a lot of people are going to see it as they bring their kids to the Polytech. It will actually be a good flagship event building. And the other thing, just moving ahead, so this was one that was built not long after the Christchurch earthquake. It was built in Nelson, which isn't far from Christchurch, and it was a showcase project because it had these transparent safety features. So with that rocking shear wheel design, there's the energy dissipator, and so it's like a fuse. If there's an earthquake, you can see that it's damaged, but you just replace that steel fuse, and the building's good to go again because it comes back up after the earthquake. And so that, we all thought in the wood industry, oh, that'll be great, everyone will love those. And I think the occupants, they're design students who are in that building. It seemed like a great idea, but I mean, it's hard to imagine that having those elements in many buildings would go down well with the occupants, but it was certainly one that sprung up as a very logical one. Getting close to the end now, but this is a project that has taken off because this is the emergency housing, 3-story walk-up, and the client is the government who has to house people in short order. And we have the same building crisis in New Zealand. We have expensive materials, we have a shortage of labor, and too many people coming in too fast. And so CLT wasn't the obvious solution here, but it's really taken off. And there's a group of people now who are collaborating, the designer, the architect, and the engineer. And that little co-op is actually, that group has got really quite tight, and they're winning more and more projects because they're able to sell all the advantages of it. And they probably go to timber earlier than they would if there was an external client. That's the Otago Polytech. It's one of the bigger buildings. And the one thing that's going to perhaps change New Zealand, because they talk about emotion, one of our biggest building owners has just made a decision to build a tall timber tower. It's going to be a hybrid, really. It's going to have a concrete structure, but CLT floors. And at the time, of course, it was, it's going to be the tallest one in somewhere. But this building owner, Robert Jones, is known as quite a blowhard in New Zealand, but he also owns most of the property in New Zealand. So we're just hopeful that everything goes well on this project, so that we don't, we've really got to make it in front of the public, because this guy lets people know when he's not happy. But watch this space. It's our flagship building for the next year or so. So just to wrap up, almost. Looking at what happens in both countries, the average job size in New Zealand in Australia is 3,000 cube compared to 100 cube, because most of our developments, until you saw these recent ones, have been individual houses and smaller projects. In Australia, 2 weeks ago, XLAM commissioned a new plant, and that's now operating, and it's producing 60,000 meters cube per annum. Well, I've been traveling here in Canada and the US since early March. There was another plant announced in New Zealand called Red Stag, and that will be 40 or 50,000 cubic meters. We already have XLAM in the South Island producing 12 or 14,000 cubic meters. And of course, we got the supply from Lend-Lease and KLH and Binderholz. And a lot of the glulam and the LVL is already supplied by companies like Carter Holt Harvey Wood Products, which is a big forest company in both countries. And so some of the key factors that could really influence the change now, we're both, Australia's finished their timber design guides through their Wood Solutions Network, and they've been in place for a couple of years. And Australia's putting quite a bit of money into promoting that into the architecture and engineering communities. And I've heard some discussions here earlier today about the cost. I was in a session yesterday where they said Brock Commons was 4.5% more expensive than traditional materials, so it had to go faster to meet, if you want to convince a developer of the pure economics. But actually, in both Australia and New Zealand, we reckon CLT's cheaper. So but it's still a challenge to get a developer. The resistance from people who are going to do a building project like a hotel owner or a developer is they worry about fire, footfall, and flooding. What happens when this thing gets filled with water, and those are some of the challenges that our new WoodWorks program will set out to achieve that. And there's another 6 objections about I don't have much flexibility in buying it. And that's all today. Thanks very much to all the people who helped us.